You in process upgrades through belting 4.0.
Zero. That's very mysterious, isn't it?
I have no idea.
You have a clue, have you?
I'm looking forward to your presentation.
Thank you very much. Okay, playing to a packed house, obviously, so I'll try and keep it brief. Thank you for coming along, and I'm pleased to see that those have turned up on time. My name is Howard Bull, as was announced. I work for Mafdel, who are an international extruder of thermoplastic belts and sheet materials. And I'm hoping that today that you'll perhaps take something back with you that may be useful in your home work. So, proceeding, just to let you know what you're in for. We're going to be talking about a brief history of conveyor belting, just to give you a bit of a reference to see where we've come from and where we're going to. The challenges before us, so we're going to be talking about the current challenges with respect to conveyor belting. You've got to remember that pretty much all the things that you have, your phone, your car, your tyres, your food, at some point touches a conveyor belt. And it's very important that you understand the things in position to make that as efficient and hygienic as possible in terms of the food industry. And then we'll be talking about belting version 4, which is something that you may be asking the question, what on earth is belting version 4? But all will be revealed. Okay, so instead of starting at belting version 1, we're going to start at belting version 0, because there was a point where there was no hygiene, no automation, there was nothing. And in fact, in that picture, you can see 3 or 4 men cutting up meat in a bowling hall in Chicago, and that was the height, that was state-of-the-art meat production at the end of the 19th century. From here, it had to get better. So what we're going to do, we're going to look at the eras of the belting trade, and we're going to see how it's progressed up to our belting version 4. So, we're going to take ourselves up to and around the 1950s. You can see here, you can see here there's a conveyor with sacks on it. You can see this is a cookie factory. This is another very similar conveyor conveying lard. So you can see the machines are very, very crude. They had wooden slats, chains. The slats were attached to chains and literally open and carrying the product up. There were metal belts. Sandvik in 1901 invented the first metal belt, but of course metal belts even nowadays perhaps have their drawbacks in terms of practicality. Wider woven cotton belts were available, but again they were a highly absorbent material where you couldn't really carry or transmit or transfer wet product on it. Rubber belts were available. Again, it was probably the best way of perhaps insulating the cotton, but it wasn't really hygienic. And then, of course, we had rollers, and those really were the mediums up to the 1950s that you could expect to have your food and products transferred on. So we're then going to go up to we're going to look first at the advantages of those in terms of that particular era. We had conveyors, they allowed increases in production volumes. Hygiene awareness was coming in, people demanded less food poisoning, less product in their food, alien product that is, of course. Introduction of production standards were introduced in America in 1906. The downsides, a high level of foreign object contamination, because of course you were transferring your products on mechanical devices, so eventually some of that would migrate into the food. Lower levels of sanitation, still had poor hygiene. As you saw from the picture earlier, open machinery would lead to injury. You get your fingers trapped, and there's all sorts of difficulties there. And of course, unreliable operation. You had rudimentary mechanical equipment, which meant that it had to be maintained, and it wasn't really as good as it is these days. So we go up to the 1960s. Here we see a picture of some ladies in a factory in South Wales in the UK producing Smith's crisps. In addition to what we saw in the 1950s, we saw the introduction of synthetic coated textile belts. They're still obviously very, very popular today in many applications. We saw the improvement of the cotton woven belts into the polyester belts, which gave them more stability. It gave them greater stability in terms of stretching and things like that. Extruded round and V belts started to make an appearance. These are the round belts that you will be familiar with, the elastic belts. The upsides and the downsides. The upsides, further improvements to hygiene. Belts became scraper friendly because you had a surface on the belt with a TPU or a PVC surface. It could then be scraped. You had better cleaning regimes possible because, of course, you had that barrier between your product and the carcass of the belt. And, of course, better stability and reliability because you had man-made fibres in the belts. The downsides, increased cases of plastics contamination because you were using plastics. Obviously, belts were shedding bits of themselves into the food, so that was becoming a little bit of an issue. Because the textile belts had laminations, they were made in laminates to increase the load carrying capacity. That was becoming a problem. They would separate and allow bacteria in between the laminates. And then, of course, you had a scarf belt joint. Instead of a finger joint, you had an overlap joint, and when that started to fail, you would then have a little pocket where bacteria would creep in. Now we're on to in addition to what we've seen before, we're on to the 1970s onwards. We saw modular belts making an appearance. You can see those there. Friction-driven monolithic belts. In other words, you have fully synthetic belts with no cords or any sort of fabrics in them, but they weren't in any way positively driven. They just drove like a friction belt. Food-grade TPU timing belts. That's this item here. We saw those coming in. We saw the introduction of belts with an infusion of antimicrobial additives. And then also we saw an improvement in the joining technique of the belts. Instead of them being scarfed, they were then made with a finger joint and melted together. And the upsides and the downsides, significant increases in hygiene, basically due to better surfaces, finger jointability, significant increases in belt width. We could obviously, instead of going perhaps from 1 meter to 2 meters, they were going up to 5 meters wide, which meant the economies of scale were much better. And also production capability was improved. You could build wider conveyors, which could pull larger loads. And of course, lower maintenance costs in terms of the modular belting, because modular belting at the time was seen as a miracle belt, which I suppose it was. It didn't need any maintenance, it didn't need any adjustment, only repairs every now and again. The negatives that existed, hard plastics contamination became a real issue. Because of the modular belts, they were brittle, fragile, and if you dropped a product on them, they had a tendency, some of them, to shatter. Fabric contamination remains an issue, and antimicrobial migration became a problem. Okay, so we're going to talk about what are the concerns of food producers in their food processes when it comes to conveyor belts. Hygiene is obviously the big one, because as I said earlier, the products that you produce, nearly all of them touch a conveyor belt at some point, so the belts themselves have to be very hygienic. Cost reduction is a big one. Many companies have shareholders, so that gap between production costs and sale value is the bit that you all dive into to make a living. Low maintenance, people cost money, and if you have lots of people in the factory trying to fix things and adjust things, that is a cost. Reliability, that obviously affects factory output. If you have belts that let you down, it's obviously an issue. And then compliance, you obviously get audited as a company, and if that audit goes wrong, it would mean you got shut down or the line had to stop until the error was corrected. Okay, let's just look at some of the problems that typically you would come across with certain styles of conveyor belting. Here we see a belt. This belt actually is a photograph of mine, of a brand new belt in a chicken factory that had not been fitted to a conveyor, and it was on the shelf like that. You can straight away see that that would be a harbour for bacteria, and also would be a risk of those fibres getting into the product. There's a picture I took of a flighted conveyor. That's a hopper there. Something's obviously been dropped into the hopper and smashed its way through the belt. And of course, the question would be is where have those parts ended up? Hopefully they ended up on the floor, but there's a high likelihood they would have ended up in the product. And of course, people that deal with modular belts obviously would be, or use modular belts would be aware of that, and they have to be careful to monitor that situation. Surface cracking is also a big problem. Obviously that belt there, and it just amazed me that that belt was still allowed to run with the surface cracks in it, because there is absolutely no way you could get that belt clean. With steam cleaning, anything you like, you'd never get it clean. Here's a perfectly good conveyor. It's a modular conveyor, but of course the cost of cleaning a very complicated conveyor is considerable, and yes, you could get it clean, but it would take a long time to do it, and that is something that does concern. You've got water consumption, you have chemical consumption, and you have, of course, you've got to get rid of the waste water. So if you have a product, for example, that eliminates that, it's a big benefit. Hygiene levels, again, I don't want to be picking on modular belts too severely, and they're a great product, but in certain applications, they are difficult to keep clean, particularly the pin area. It is difficult. And then on textile belts, you can see here's a conveyor belt, and this area here, between here and here, is what we call delamination, and that's where the layers have separated. And again, virtually impossible to clean, and somebody is conveying their food product on that, and it's not a good situation. And then finally we've got a picture of, and I'm sure those of you that are familiar with a food environment, you'll have seen this. This is where a belt tracks off and destroys itself against the conveyor, and the edge just fractures. And again, all the bits that used to be attached to the edge of the belt will be somewhere. They may be on the floor, but more likely they'll be in the food product. Okay, so where are we now? Let's have a quick reminder. Things that are important in the food industry to your basic food processor: hygiene, cost reduction, low maintenance, reliability, and compliance. And so I'm going to introduce to you what we regard as belting version 4, and that's the subject of the title of this presentation to you. Belting version 4, oops, there. And it's what is known as the positively driven monolithic belt. And that's something that that's a product we manufacture. And it is a belt that is fully molded, that's the definition, fully extruded, fully molded, a single material with no fabrics or other materials incorporated. There are products that surround that product. Some of them may have fabrics in them, and they're there for a reason, and it's a justifiable reason. We put fabrics in ourselves, but under certain circumstances. And also there are other products where a lot of those products are welded on, they're not molded on, so there's a high likelihood that they become a hygiene issue or may indeed fall off. How does a monolithic belt improve the hygiene? There are no plies to delaminate. There are no cords or textiles to contaminate. Solid sprockets with no voids. Resistant to hard plastics contamination, and I always say it, You could put one of those belts on the floor and hit it as hard as you like with a hammer, nothing will fall off it. So it's a real tough belt. Hygienic welded joints and a smooth, scraper-friendly surface, which is very, very important if cross-contamination and things like that could be a worry to you. How does a monolithic belt reduce your costs? Excuse me. Clean in place, you don't have to remove the belt to clean it. It's a completely smooth and molded entity which can be cleaned in place. 70 to 80% lower water, chemical and waste usage. So if you had a factory which was previously running on an alternative belt and you went over to a monolithic belt, you would expect to see that sort of reduction in water usage, purely because it's so much quicker to clean. Fit and forget, and I'll come to that in a moment. It can be mechanically joined, so if you really do want to remove the belts from the conveyors, and it's something that you want to give perhaps something a deep clean, you can remove them and use a mechanical joint to refit them. No specialist joining skills needed. If you wanted to come along to our booth this afternoon, I could probably have you up and running in about 20 minutes. Can be joined quickly and easily, and it results in a simplified conveyor construction. You'll see that. I've got a little video to play a little later, and you'll see how simple a monolithic conveyor can be. Reliability, no need for tensioning because these belts run slack. They run like a modular belt. That's one of the benefits of a modular belt because there's no stress on the bearings or the conveyor frame itself. Self-tracking, it won't track off. Tough and durable. Low fatigue on bearings and frame. I mean, again, those of you that work in a food environment, working with textile belts under tension, you will see metal fatigue eventually in the frame and you'll have to send somebody along just to weld in a crack. And can easily be repaired. That's a question that comes up fairly frequently. Can these belts be repaired? Yes, they can. You can put a piece in, or you can weld a split. And how does a monolithic belt comply? Well, I can talk about Mafdel, HACCP friendly, EU compliant, USDA and FDA compliant, and 50 to 80% quieter than a modular belt. They run very, very, very quietly. So now we're going to see a little video, and this will show you how simple a monolithic belt can be. You can see that the side of the conveyor is completely open. So when I talk about cleanability, you won't get a conveyor more easily to clean than that. This is a troughing conveyor. So you can trough the product, you can carry dough with it typically. You can see this conveyor has a central spine with just a tail roller and a head roller, with outriggers supporting the conveyor supports. And a lot of the features and the cleanability is self-explanatory. This is the tool we use to join it. It's a simple butt weld. You don't have to cut fingers in your belt. It's a case of literally melting the ends of the belt. You join them together and then you trim the flash off the joint. Just like that. You can see the engagement. This is like a snowmobile sort of principle where the sprocket sits in a double track of teeth. That's just there to prevent finger traps and things like that. And there you are. That's your simple, standard, monolithic belt. Zero tension, self-tracking, inexpensive, troughing and quiet. Okay, we're coming to the end of the presentation now. The question is, what's possible? And again, I want to emphasize the simplicity of a monolithic conveyor. It doesn't take a lot of imagination to imagine yourself stood there with a jet wash lance cleaning it. It goes straight through. This is a troughing belt. This is a cantilever belt, so cantilever conveyor. So you can take the belt off the conveyor and replace it very easily. So again, the key benefits of a monolithic conveyor belt: no fabric contamination. You won't see fabrics in your product anymore. No delamination, you won't have any little harbours for those nasty little bacteria that cause you liability. Resistant to hard plastic shedding, no harbours for bacteria. Simple to retrofit, that's another thing if you have a conveyor that you want to change over to a monolithic conveyor. It's a modular belt conveyor, very, very simple. If it's a textile belt, very, very simple. So you're not talking about having to buy a new conveyor, you can convert your existing conveyor. Fit and forget operation, you basically put the belt on, you don't need to put any tension into it, and you just switch it on, and it works. Quite an operation. Water, chemical and labour saving, big cost reduction, especially nowadays with energy costing the way it is. And it's fully compliant. So there you are. That's the end of my presentation. I don't know how I did. Oh, 21 minutes. Okay. So thank you for your attention. And I was wondering if you had any questions about oh, this gentleman, I think, wants to invite the questions. Is that happy enough?
Yeah, you're welcome to ask some questions, or you're invited to contact.
Okay, yeah, well, you'll find us in Hall 7 at booth A28, where we have a team of people ready and waiting to answer all your questions and take your orders, if you have any, of course. And thank you very much.
Thank you
Thanks for the
for
opportunity.
coming. Nice to have you here.
Thank you.
A lot.
All the best. Thank you.
Now, we will continue here at the stage with our next presentation at 12 o'clock.